Hash tables and hashing aren't just theoretical concepts. They are critical to your career growth in tech. A solid understanding of these topics will help you excel in software development, data engineering, and system design roles and give you a competitive edge in coding interviews. In this video, we will start by introducing you to hashing, what it is and why it's essential. Next, we will break down how hashing works, focusing on the role of hash functions and the methods used to handle collisions like chaining and open addressing. Once we have covered the basics, we will dive into the practical side, starting with hash tables and how they provide synchronized key value mappings. We will then explore HashMap, a faster, unsynchronized alternative, and look at LinkedHashMap, which preserves the insertion order. We will also cover HashSet for managing unique elements and wrap up with LinkedHashSet, which combines uniquenesses with order preservation. By the end of this video, you will have a solid understanding of hash tables and their variants, setting you up for success in coding interviews and beyond.
Now let's talk about the concept of hash tables. So what is hash table? How is this hash table implemented in Java? Now before understanding all that concept, we have to understand what is hashing. So because hashing is a concept which is being utilized when we talk about implementation or coding of hash tables or hash map and so on. So what is hashing? So hashing is a black box technique in which if you pass a key, the key can be anything, a number or a string. If you pass a key to that black box function, the output will be a code that is called as your hash code. Okay, now why this input and why this output? What is the whole concept? Why is it required first of all? Okay, so let me explain you. So suppose I'm talking about a function. Okay, let this be represented as h of x. Fine. Now this will pass a key. Okay, this key can be a string, it can be an integer, it can be anything, any number or a sequence of characters, anything. Okay, output will be a code, also called as your hash code. Okay, now what does this hash code is used for? So hash code tells the position where that particular key is going to be stored at the backend in the computer system. Okay, for example, suppose there are these many, this is your array you can assume, or this is a space which is there where your data will be stored. Fine. Suppose the data example I'll take is of a student. Okay, so a student will have its name, will have its roll number. Okay, now this data has to be stored somewhere. When we talk about the storage in RAM, that is a temporary storage, right? So when we talk about storage in RAM, this is how the storage is structured. So suppose this data about a student who has a name and a roll number has to be stored somewhere. Okay. Now that data or that name of a student suppose is a key. Okay. That key will be passed to this hashing function or hash function. And the output will be a code. That code will be nothing but that position in the storage area where that particular data of a student will be stored. That name or roll number of a student will be stored. Okay, suppose the key or the name of a student is something called as maybe ABC. Let the student name be ABC. So ABC will be the key which will be given to this hash function, and output will be a code. This code is suppose for ABC key is your 4. Okay, so starting from 0, 1, 2, 3, 4, and suppose there are more numbers, more storage space here, 4, 5, 6 and so on. So at fourth location we'll store the data of the student ABC. Getting it? Next, suppose there is some other another student or whose name is maybe Priya. Okay, so Priya name will be this key. It is a key here. It will be passed to this hash function, and the code or the output which we get out of this hash function is suppose 2. Now at second location, the information or the data related to Priya student will be stored. So this is how hashing works. Okay, this whole concept of finding a code out of a given key. That key can be anything, either a string or either an integer value. Like in this example, it was a name. So for the Priya name, the code was, or the output of this hash function was 2, and we stored there. So this is the complete concept of hashing. Okay, so you can say it is a one-way function, meaning if you provide a key, it produces a code or a hash value. Okay, but if you provide a hash value, it won't produce a key. Right, now what is this function? So this function is designed in various ways. This function can be like as simple as picking the last character of a string and converting it to its ASCII value, and that ASCII value becomes the index or the hash code. Okay, or it can be as complex as some mathematical calculation over the ASCII values of a given string. So we are not no bothered about what this hash function is going to be, although the complete hashing concept depends on this hash function itself. The more better and well structured your hash function is, that good the complete hashing technique will be. Why I'm saying that? Because a good hashing technique is only that where there is minimal collision. Now, what is this collision? So we'll take this example again and see. So the same hashing function, I'm going to take another example. Okay. Now, let's see here. Suppose there is a student called by the name of Priya. Okay. Then another student is there by the name of maybe Pooja. Then there is another student maybe by the name of, you can say, what, Rohit. Fine. Now, we have to store these three data or three names of a given student into the storage space. Now, Priya will be passed to this hash function as a key. Okay, it will produce a hash code. Suppose it produces the hash code as 2. So this Priya will be stored at location 2. Then there is another student named as Pooja. It will be passed as a in the hash function, and it will produce the hash code to be suppose 4. Okay, at the fourth location we'll store this Pooja. Now next is your Rohit again. So Rohit is passed in this hash function, and the hash code which it produced was again 2. But at the second location already there is another information about a student named Priya is stored. So where will this Rohit be stored? Now this complete situation is called as your collision. And a good hashing function should avoid this collision situation. Okay, so when we talk about its implementation in Java and where it uses hash map and hash table kind of a concept, there this collision is resolved. Now, how is this resolved there? It is resolved by using the concept of linked list. It means what? Like, suppose the second student here, Rohit, also had a hash code of 2, but 2 was already occupied by another student information, that is Priya. So what will happen? There will be a pointer to from this place, that is second index, to another node. Okay, and this node will be having the information. This is a node of a linked list. Okay, and this node will be having the information of a student Rohit. This will also be like one node of a linked list. Okay, which will have the value, that is Priya, the name of the student, and the address to the location where this node is. Like how in linked list it is. Every node of a linked list stores a data and a pointer to the next node, right? Similarly here, the data will be the student name Priya, and then address to the next node, that is this node where the Rohit information is stored. Getting it? So this is how collision is resolved. So there are multiple techniques to design this hashing function. Then there are multiple techniques also to resolve the collision whenever it happens. So one of the way I told you is by using the concept of linked list. So all those keys which are mapped to the same location are linked with the concept of linked list, or linked as a nodes. Okay, but we always try to have a hashing function which has minimalistic collision, and that's a good hashing concept or a good hashing technique. Now we'll talk about what are those ways in using which we can implement these concepts of hashing and how it works when it comes to Java programming language. Now let's talk about the implementation of the concept of hashing in Java programming. So for this, what will be the problem statement is that we are going to write a program using which I'm going to tell you how this hashing concept works, or what is hash code, and then what are different hashing functions which we can use in Java programming. So, guys, there are so many hashing functions which already exist like MD5, SHA. All these hashing functions produces 16-bit hash codes. So you can do the direct implementation of these hashing functions also. But even if you don't do, like, how in a most simplest way you can use the concept of, or is Java using the concept of hashing? So for that we will talk about two of the concepts of collection framework in Java. One is your hash map, and the next one is your hash table. Okay. So hash table is an interface which is defined in the collection framework of Java, which will be making use of directly here to write down the code and understand the whole concept of hashing. So what happens basically is, so let's try to understand that first, and then I'll come to the coding part. Suppose I'm using the concept of hash map. Okay. Now hash map is kind of a associative array where there are two fields. Okay. One is your key, and other is your its value. Okay, so this pair is always stored in hash map as well as in hash table. Both is same, just with a few minor differences, which I'll tell you what is the difference between them. So key and value pair will be there in both hash map and hash table. Taking example of a student data. Okay, so every student will have a name, and suppose that student name will have a roll number as well. Okay, so every name of a student is associated with roll number. Let's take few examples. For example, Priya is a name, and the roll number of student Priya is 3. Pooja is another name of a student. Roll number of the student Pooja is 2. Then Rohit is another student whose roll number is suppose 6. Okay. Now, how hashing works here? So what happens is when we create a hash map and store these values there, backend what happens is that this particular key, that is Priya is a key here, Pooja is a key here, Rohit is a key here, and these are the associated values with that. Okay, so for the key Priya, this Priya will be passed to the hashing function, which is an inbuilt hashing function when we use the concept of hash map and hash table. In fact, for every other objects which we create of the wrapper class in Java, there is a hash code. I'll show you the implementation or whatever I said right now in the IDE also. But try to understand first here the concept, the logic. That is, the student Priya is passed in the hashing function and it generates a hash code. Okay, and suppose this hash code is generally a very lengthier one, like it will have 10 digits or 11 digits or something like that. So which is you can do modulus operator on this and reduce it to a smaller number also, like suppose mod 10 I do, then I'll get one single value, right, of as a hash code. So you can do that, but normally, like by default, a longer 10 digit or 9 digits or 11 digits, some this kind of a hash value is generated. Okay, and depending on that hash value, suppose the hash value, and after doing mod operator or reducing it to a smaller size, I get a value of maybe 20. Excuse me. Okay, maybe 20. So in that case, this what will happen that at the backend at location starting from 0 somewhere at location 20, this information Priya and its roll number, the other value also, that is 3, both of these will be stored, Priya and 3. Getting it? Similarly, for the key Pooja, only as key will be Pooja here, the name of the student, which will be passed to the hashing function, and hash code, one hash code will be generated. And that hash code, suppose generated is maybe 25. So at 25th location, okay, the information about the key Pooja and its associated value, that is your roll number, both will be stored there. So Pooja and associated roll number, that is 2, will be stored there. Getting it? So this is how the hashing concept or hash code concept is being used by these two um, collection frameworks or the concepts of collections of Java. Now let's see the implementation or coding part of it, and let's go to the IDE now. Okay, so here you can see I have already created a class named as hash, and there is a main method, public static void main here. So now let's go to directly seeing how the concept of hash code actually works in real scenario. So for that, I'm going to create a hash map. Okay, so hash map, as I said, it takes two value, the key and the value of the other element. That is the example we saw, name and the roll number, right? So two values will be there. So similarly, you have to provide the data type also for those two values. So if I take name and roll number, the same example continuing further as implementation, then name will be a string value and the roll number will be an integer. So let's take a string and then integer. Okay. After that, we should give a name to this hash map. Let that name be student. Okay. Then new keyword, which is equal to new keyword, which is used for allocation or creation of an object or allocation of space basically for the student hash map. So okay, new keyword and then again hash map, and then again you have to provide the data types which we have already provided, that is string and integer, and then round brackets and colon. That's it. Okay, it's showing some error. Let's see. I think you have to import it. So yeah, let's import this hash map. Okay, so hash map is declared here now or created here basically. Now let's add the student information, that is its name and roll number. So to do that, we use a concept of, or we use a method that is called as put method. And how it is called? So let's see, student dot put, and in the bracket you have to provide two values. First will be your name, that is maybe your, let's take Priya as a name, and let its roll number be, this will be a integer value, so 3. Okay, so I'll just copy paste this again and again just to save time, guys. So if you put here 3 students, suppose I'm going to put, so Priya, Pooja, okay, Rohit, okay, these are not my friends, just simply I've taken the names, and suppose 7. Okay, now to get the information, like okay, I have stored it, now let's check has it been stored correctly. So if you'll give a key here, it will give you the value, that is the roll number of that person, the student, as an output. To do that, how can you use, just see here, student dot uh, get. Okay, okay, we'll do one thing, let's put it under the for loop so that we can use it for all. Now, again, for before putting it in the for loop, there are two ways by which you can iterate over a given hash map. Let me tell you both of that. So two ways are there by which you can iterate over a hash map. Okay, one is by simply using the concept of set, and other is by using the concept of entry concept. And that, what is that, I'll tell you. So first, let's see the concept of set. Okay, so what you will do is we'll create a set here which is of type string. So all these data of the hash set will be converted as a type of set. So let's create a set first here. Okay, and to do that, we use set class and then string, the data type for that, and then any name you can give. I've given data as a name of the variable of that set variable. So data on, and then we can call student dot key set. Okay, so I'm going to make the student hash map as a set of data or a set of keys. Okay, think we have to import this also. Okay, let's import that. Now we can use for loop on this. Okay, so I'm using for each loop concept where string I for data. What I'm going to do is I'm going to print. Now here I'll use the get method. So get method, put method was used for storing the data. Similarly, get method is used for fetching the data. So get of I. So we can see here. Now let's run this code. So you can see that with respect to all these names, all these keys, we got 3, 2, and 7 as here values for them. They're all numbers. Now suppose you want both to be printed, the key as well as its value, that is the name as well as their all numbers. So for that, you can use another concept is there, which is your entry set concept. Let's see what happens there. Okay. Okay. So after this. So in this, what we'll do is we are going to create entry set. Okay, and this takes map dot entry, and the data type will be a string and integer, because this time we are creating in pairs this entry set. Okay, so it will be in pairs, a string and then integer, the name and the roll number. Okay, and then let it be data1. I just change the name of student dot entry set will be called as a function, then semicolon. Okay, this is how we create a entry set. Okay, now using this again for each loop on this entry set, we are going to iterate over the given hash map. So for again, but here there you see that data type was string, right? But here the data type will remain same, that is map dot entry. This will be the data type, and here you should write string, and then you should write integer I colon over data 1. Okay, so in this we are going to iterate, and then I'm going to write the same thing, that is I dot. Okay, the here function is get key. So this will tell you the complete key, that I mean that is your name of the student as well as its roll number together, because you've created the entry set. Okay, so get key will give you the key, and then you can have again I dot get. So you can see here the get key, get value, get class, three methods are there. Get key we used, which will tell you the string part of it. When get value you do, it will tell you that integer part of it. So we'll use get value. So both we can get the key and the value, that is the name and the roll number of the given student. Okay, so that's it. We'll save the file and then just let's run and check. So you can see here, this is the output of the earlier for loop. And then this is the output of the second one, that is entry set we used. So this is how we iterate over it. Now, let me here tell you where is the concept of hashing here used. Okay, although I have told you that when this particular no, set, that is the hash map, that is the name of the student and roll number is stored somewhere, first the hash code is generated for it, and then it decides the position of that particular data to be stored at the backend. Let's print here I dot hash code. So you can see here the hash code is an inbuilt function already in Java, which helps you to get to know what is the hash code generated for each of this data. So I here is nothing but the key, that is the string part here. That is the name of the student in this example. That is Priya, Pooja, and Rohit. Okay, so let's see what is the hash code generated. So guys, you can see here, okay, I will just comment out some of the lines. Okay, so that it's easy to understand the output. So you can see the output here. So it has generated the hash code. First one is for Priya, the second one is for Pooja, and the third one is for Rohit. Right? So this is the hash code generated. Okay, one more thing. Okay, it's not necessary always that this is how the order will be. So let's print this for that matter and check what is exact hash code. So 3 is the roll number. So 3 is Priya itself. So its hash code is this one. Then 2, its hash code is this. And then 7, its hash code is this. So you can see how longer hash codes are generated by default. So most of the time what we do is we get, we get mod of n, and this mod of n we do, n is nothing but the total space that is there. Suppose initially we use a number of, it's a, suppose we are using arrays to decide the position. So suppose the array size is 10, so we'll do mod of 10. What is the total complete size where these datas are going to be stored? That becomes your n, that is used as a mod here to bring the complete hash code to that range. So if you do mod of 10, it will come to the range of 10 storage space. Okay, 10 indexes. If you do 12, it will come to 12 indexes. Okay, so in that range it will come. So let's see what's the output after that. So you can see here for 3, the 3 roll number, that is Priya, the hash code is 9. For 2, the hash code is 2. For 7, hash code is 0. So you can see it is stored at that particular location ranging from 0 to 9. When you do mod of 10, it is 0 to 9. Okay, so these at the backend, what would have happened at is that these particular data would have been stored at this particular indexes. So that's how the concept of hashing works inbuilt or by default in Java programming. If you can see this by the whole help of the concept of HashMap, or even if you don't create HashMap, like Suppose directly I create a string here, a is equal to, and hello, suppose. And if I try to print, okay, this will be capital S. And if I try to print a dot hash code, then also you can print the hash code value. So it's always that there is a hash code generated. So this is the hash code for string A. Okay. So that's all about the concept and implementation of hash map and hash table. So hash table, guys, it's similar in implementation, just that here you have to use hash table in class, and then you have to import this as well. And that's it. It will work in the same way without any error. Okay. But there is a difference between hash map and hash table. Okay. Uh, One is your, hash table is your synchronized and hash map is not synchronized. I mean, hash tables are thread safe. So, and hash maps are not. So that's a different concept here altogether. But that's how hashing is implemented using Java programming.
So first of all, we'll try and introduce you to hashing, and then we'll continue to understand how exactly this hashing works, right? And next, if any collisions occur during your hashing process, how to handle such collisions, right? So what are the different techniques to handle such collisions? Next, we are going to check out the implementation for the hash table, hash map, linked hash map, hash set, and linked hash set. All these are nothing but the collections in Java. So we'll try to implement all these and understand different methods associated with these particular collections in Java, right? So let's get started then. In this video, let me introduce you to hashing. Okay, so here, what is hashing? Okay, what are the different uses of hashing when you use it in your program or when you're writing your application? Let's check out those in this particular video. All right. So first of all, what is this hashing? Okay, so you can say hashing is nothing but a code. Okay, so say for example, you have your name. Okay, so you have your name, and if you want to convert this name to some code, okay, let me say I'm going to hash your name. Okay, and that hashed name would look something like this. Okay, so 1 A B and some symbol dollar. Okay, so it's not mandatory it should look like this. So it's like you have a name, you're going to apply some method and convert that particular input to a different form, something like this. Now, how hashing will play an important role when you're writing a program using Java? Okay, so in Java you have something called as collections, right? So collection examples are, you have hash map, hash set, linked hash map, linked hash set. Okay, so what are these collections? Collections are nothing but readily available classes with which you can implement your applications. Okay, so those are your collections. Now, hashing is nothing but a unique code which will be generated for your values. Okay, you can pass any value, okay, to your program. That value will have an attached hashing code. Okay, with the help of this hashing code, you can perform operations such as search, delete, or insert, or any other operation very easily. Okay, so say for example, if you want to search for a particular value inside your linked list. Okay, so one option is you have to search from beginning till the end, right, in the worst case. Okay, so the time complexity would be O of n, right, until you traverse till the end of your linked list. But here what you can do is you can simply calculate the hash value, and once you get the hash value you can simply store that value there, or simply search for that value with the help of this hash code, right, which will narrow down the your search operation, right? So in such cases hashing will play an important role. That is why it is very important to learn. Fine. So here, as it is written here, hashing is a method to allocate a unique code for any object. Okay, so in your programs you have your objects, right? So all these objects will have its own unique hash code, okay, to identify themselves in the program. Fine, that is your hashing. Now, the problem of finding or storing or any other operation in your program will be very shorter with the help of this hashing method, right? So, in collections such as HashMap or HashSet or any other collection in Java, if you use this hashing method, all the operations duration will be short. Fine, that is the advantage of this hashing technology. And then you're going to write a hash function or an algorithm through which you can map your data with some integer value in your program. Fine, so that is how a hash code will be generated. Now, one more important thing to note here is every hash code you generate, okay, should be the same every time you run your program. Okay, so any two same objects must return the same hash code every time you run your program. Okay, your function or your hash function should take care of this particular point here. Now, what is the use of this hash code? Okay, so what it will do is it will narrow down the search operation, right? So in a linked list, if you want to search for a particular item, you might get it in the first location, the middle location, in the last location, or anywhere, right? But the problem is, in the worst case, you have to traverse till the end. But here, with the help of this hash code, easily you can check for that in a hash table. All the hash codes are stored in a hash table. Okay, so whatever value you want to search, you get access to the hash code. You can directly go to the table and access that particular location using the hash code. Okay, so this will narrow down your search operation and other operations as well. Fine, so I hope with this you have understood the introduction to hashing part. Fine, thank you. Now we are in our next topic, which is how does hashing work. Okay, so here we'll try to understand how exactly this hashing works. Okay, with an example I'll try to explain how exactly in the background this hashing works. So hashing, as we know, it's a unique code, right? Now what we do is we try to store the information in the form of a key and value pairs so that we can easily identify the data with the help of this key, right? So it's always a key and a value pair. Okay, now this key is nothing but the input to our hashing function here. Okay, so we need to apply this hashing function in order to extract the value, right? Every key has associated value. Okay, now this key has to given as input to the hash function so that we can access the value present at that particular location. Now all this information is stored inside a table called as hash table. Okay, now all this hashing code, okay, the key and the value, everything is stored inside a hash table internal. Okay, now you need not worry about this. All you have to worry about is what is this hashing, how does it work, and what is this hashing function, right? And after that, your hash table should also support the basic functions like, insert, get, that is extract, and deletion operations, right? So in generally these three functions must be supported by your hash table. Now this code, generally it is an integer code. The hash code what we're talking about, it's generally an integer code which is always mapped to the object using your hash function. As simple as that. Now the thing is, how does it work? Okay, so let me take an example. Suppose we want to store list of countries, okay, and their capital cities. Okay, so we want to store this information. So how do we apply hashing to this? Okay, what we can do is we can consider the country names, okay, as key and the capital cities as the values. Okay, so for me, if I have a country name which is a key, then an associated value is nothing but the capital city of that particular country. Okay, now country is the key and the capital city is the value. Fine, so let us try to explore this example more. So consider this table over here. Okay, now here we have countries such as Oman, Italy, Russia, Croatia, and Indonesia, right? and on the values column we have the capital cities, right? So this position is nothing but the index value. Fine. So internally what will happen is, whatever key you have, so say for example you have Oman, right? So you have Oman here. So this Oman will have an associated hash code. Okay. And that hash code will make it store at this location 4. Now in this example, to keep it very simple, what I've done is I've considered the count of that particular country name as the index value or the hash code. Okay. So say for example, Oman is 1, 2, 3, 4 letters, right? So it has a length of 4. So what I've done, I've stored it in the index location 4. Okay. And the associated value is nothing but its capital city, which is Muscat. Fine. Similarly, the length of Italy is 5. So I've stored it in the index location 5. Russia is 6. I have stored it in this location. Croatia is 7. I have stored it here. Fine. Similarly, we have the capital cities as the values. So these are your keys. So in this example, based on the length of that country name, I'm locating it in those positions. Fine. Now we have one more, which is Indonesia, which is 9. We have located it at the index location 9. Fine. Now what is the problem here? Now can you see the positions 1, 2, 3 and 8 are blank? Okay, because as of now we don't have a key value for the position 1 and for 2 and 3 as well. So these are wastage of our memory, right? If we don't have anything to store, suppose if we have allocated so much memory, so this is one thing to consider. Now to understand it in simple terms, we are considering our hashing function as finding out the length of that particular country. In this case it is Oman, right? The first insertion operation, right? So it is 4. We are simply inserting that in the position 4. Now the problem is, what if we have another country of 4 length? Okay. So that time what will happen? A collision can take place, right? So suppose if you have one more country with a length 4, right? So you should design your hashing function in such a way that it should take care of the collision as well. So this was a very simple example for you to understand. Like this, you can design the hashing function in such a way that it should also take care of the collisions which might happen in the future, right? Now, suppose if I want to insert one more country name, let me take India. Okay, so what is the count of India? 1, 2, 3, 4, 5, right? So if I want to store this, I have to store this at this particular location, right? That is here, right? But we already have one more country there, that is Italy, right? So there is a collision taking place over here. So you should design your hashing function in such a way that it should also take care of collision. Fine. So I hope with this you have understood how exactly hashing works. Okay. And what is this hashing function and how this hashing table looks like. Fine. Thank you. Now we are in our next topic, which is collision handling, right? So it is very important to handle the collisions which might occur in your hash table, right? Because those can cause a lot of problems during your hashing. So let's see how to handle collisions. There are generally two methods for handling the collisions. Let's check out those. So the first one is called as separate chaining. Okay. So how do we handle this collision with the help of this separate chaining? Okay. Now just look at this example over here. That is this table. Okay. So if we have this country, okay. So suppose we have this country Oman. Okay. So this Oman is nothing but our key value. Okay. And the capital city of Oman, which is the Muscat, is nothing but the value, right? So this is our key value pair. in this particular example, right? So if you want to store this information in a hash table, so what we'll do is we'll just count the length of this particular country just as an example, and we'll consider that as the hash code for our indexing. So OMAN is nothing but 4, right? So what we'll do is we'll simply place that in the location where 4 is pointing to, right? So now after this, what we have is we have a country called as Italy, right? So which is of 5 characters, right? ITALY. Okay. Now the capital of Italy is Rome. So that is what is being stored here at the position 5, right? Now the problem occurs when there is one more country with the same length. That is, we have India with the same count. So how do we solve this problem, right? So for that, what we can do is we can use this separate chaining method. Okay. So what this will do is, due to the same index values, okay, we can use this separate chaining method wherein we are going to use the linked list. Okay. With the help of this, we can allocate the values in a chain format. Okay. So look at this particular scenario here. Italy and India both are of length 5, right? So both should ideally be placed here. But what is the solution for that? We are going to link both the key value pairs, right? So Italy, Rome linked to India and Delhi. So this is how you can solve the problem which might occur in your hash table, right? So in this particular example, we are going to solve the problem in this fashion. And then we have another country, that is Russia, which the capital is Moscow. We don't have any problem, right? And similarly with Croatia. Fine. So this is how we are going to solve the collision handling with the help of separate chaining, wherein we are going to use a linked list, right? So next up, we'll try to see one more solution for this collision handling. So there is something called as open addressing. Okay, now what is this open addressing? So let me take an example. All right. So you have these locations. Okay. Suppose you have some value over here and some value over here. Okay. Now, if you want the next value to be placed in this location, okay, but this location is already used by some other value, right? So what is the solution for this? You are going to find out the next available blank location to fill in the next incoming value, right? So this is the solution for handling another type of collision, right, which is open addressing, because you cannot store two values here, right? So suppose if you want to store one more value such as minus, right, you cannot store it in the same place, right? So you are going to store it in the next available location. Okay. But this solution is not that good as of a separate chain, right? Because here in open addressing, there is a restriction on the usage of storage space, right? You can sometime exhaust your storage limitation, right? So that is the problem with this open addressing collision handling technique. Okay. And some more methods under opening addressing are, you have something called as linear probing and double hashing, right? So if you are going to compare this with separate chaining, this process is slightly slower. Okay. So it all depends on what type of application you are going to use. Okay. So based on that, you are going to decide. If you're okay with the slower process, you can use open addressing, but if you want a smaller or faster operation, then you can go with separate chaining method. Fine. So I hope with this you have understood how to handle collisions in hash table. Thank you. Now we are in our next topic, which is hash table. Now, what is this hash table first of all? So it is nothing but a class which implements hash table, and it is a part of Java collections framework. Okay. So there are a few different things which you should know about hash table, but I think if we implement this hash table in Java, you will get a better understanding of this particular collection. All right. So let's quickly jump to demonstration part. So here we have the implementation for the hash table. So due to the time constraints, what I've done is I have the program for you people here. Don't worry, I'll explain each line so that you'll have a crystal understanding of what exactly this hash table is all about. All right. So first of all, you have to import this hash table class from this library, that is java.utility. All right. And then we will also import one more file from java.utility, which is the iterator, that is to iterate the contents in your hash table. Now we will start our program by declaring a class, giving it a name hash exam1. Then we have our main function. So now the first question is how to create this hash table. Okay, so hash table is a class. Okay, and in the angular brackets we are going to pass the type of hash table. Okay, so if I want to store one integer as the key, okay, and string as the value, I can do that as well. Okay, so it's up to the programmer, he or she wishes to store the key and the value in what type of data. Okay, so in this example I want to store an integer value as a key and string as a value pair. Okay, so hash table is nothing but it's a way to organize your key and value pairs, right? So after that we are going to create an object of type hash table, and on the right hand side we are going to allocate memory, right? So here it's not necessary to pass integer and string. So if you do it on the left hand side, it is understood that you are going to pass the same values here. So then the next question is how to insert the values, right? So once we have defined the hash table, the next step is to insert some values into our hash table, right? So how to do that? We have this method called as put method. Okay, so this put method will help us to insert values into our hash table. So for that, what you have to do, simply use this object what you have created of type hash table. So ht dot put 1 comma a. So what is 1 here? It is our key value, key, right? So 1 is nothing but key of type integer, and a is the value which is getting stored with the help of this key 1. Now what happens exactly here is this key what you have here is being converted into a hash code. Okay, so that hash code will help you perform operation quickly, such as the searching operation or delete operation, right? Any operation which you want to perform will be done quickly with the help of this hash code. All right, so that is the reason we have the key value here and we have the value here. Fine. So similarly, I'll be inserting some more key and value pairs. So 2 and B, 3 with C, 4 with D. So this is our insertion part, okay, wherein we are inserting these key and value pairs into our hash table. Fine. So after that, what we're doing is we are simply printing the contents of our hash table. So for that, what you can do is you can simply use this ht, which is of type hash table. Fine. So after doing that, we'll try some more methods, right? So we'll try to get the value with the help of the key. Now observe here, with the help of key 1, we are trying to get the value, that is ht dot get 1 will get the value present at the key 1. Okay, and that value is being stored in this variable val. All right, and after that what we're going to do is we are going to simply print whatever is present in the variable val. Fine. So not necessary it should be 1, you can take anything. Let me do it for 3, right? So whatever is present at the value present with this key 3 will be displayed. Fine. Next we'll check out one more method, that is remove method. Okay, so here we are going to remove whatever is present in the value pointed by the key 2. All right, so here what we're going to do, we are going to simply pass the key value. So here I am passing 2. So what is present at the value here? It is nothing but B, right? So what will happen? B will be removed from our hash table. Fine. So that is the job of this remove method. Now after that, we can also use an iterator method. Now this is what we have done here. Okay, observe this. So import java.utility.iterator. So if you want to simply traverse or print the contents of your hash table, fine. So what you are going to do is you are going to take help of this iterator class with one more method called as keyset.iterator. Fine. So what we are trying to do here is we are trying to iterate through our hash table. Alright. So this is the syntax for that to declare it. And then we are also going to use a while loop, the object which you have created with the help of the iterator class. So itr dot has next, right? So what this has next will do is it is going to check if there is any element present in the next location or not. If yes, it is going to return true. If not, it is going to return false. So while itr dot has next, that is if there is any element present in the next location, then go inside the while loop and execute all the statements, right? So here what do we have? We have integer dot next, right? So again here we are checking if any element is present. If it is present, then simply return it. Okay, we are storing that in this variable key, and then we are trying to get the value present in that particular key location, right? So ht dot get key, right? So we are starting from the beginning, right? And then we are trying to print whatever key and value pair we have iterated, right? So that is the job of this particular code here. Now what we'll do is we'll simply run this code and check the output and also try to modify the code present over here, right? So let me just save it and let me run it. So can you see the output here? So we have these contents, that is A, B, C, D, right? We have A, B, C, D. So now 1 is equal to A, 1 is mapped to A, 2 is mapped to B, 3 is mapped to C, and 4 is mapped to D, right? So this is what this particular printf statement is doing. And then what we have, what is this C? Where has this C come from? So if you see here, we are trying to get the key value here, that is ht.get3. We are passing this, storing it in this variable val. Okay, and then we are trying to print whatever is present in this variable val. And what is that? It is nothing but C, which is present at the location pointed by the hash code or the key 3. Fine. Now after that we are trying to remove whatever value is present at the hash code pointed by this key value 2. So what is present? B, right? So we are simply removing B from our hash table. Fine. So after that we are using the iterator method and trying to iterate through the hash table. If you see here, we have 4 which is having the value D, we have 3 which is having the value C, and we don't have B here, right? Because we have deleted that particular key and value pair, right? So ht.remove, we have passed 2, that is it will delete this particular content from our hash table, as simple as that, right? So finally when we iterate, we are going to see this particular output with the help of this iterator method. Fine. So I hope with this you have understood how a hash table is declared, what are different methods such as ht.get, ht.remove, ht.keyset, right? Now let us try to modify our code. Okay, so what I'll do is let me just try to store null in the place of this particular value. Okay, and let's me save it and try to run it. Okay, so can you see here, we cannot store a null value either in the place of a key or in a null. Okay, so that is the rule of a hash table. Okay, so let me change it. So let me make it D. Okay, and this time let me make null in the place of a key. Okay, So I've saved it. There is no warning here, right? But when I try to run it, I'm going to see an error. That is exception in thread, right? So always remember, we cannot give null value to our key or value. Fine. Now what I'll do is I'll try to duplicate my key. Okay. So what I'll do is let me write E here. Let me write E. Okay. Now look at this here. All the key and value pair. Okay. But the key 4 is repeated, but the values are different, right? We have D and 4 here. We have E and 4 here. Okay. So what could be the possible output? What will our hash table do? So let's check that. Okay. So let me not delete this time. Okay. Let me comment this part. Okay. And let's try to run our program. Fine. So can you see here? 4E, whatever is the latest value present in that repeated key. Okay. So I have 4D, 4E here, but it is displaying 4E, 4E here. That is, it is considering the latest value of that particular key, right? So we cannot store duplicate key values here. Fine. But we can store duplicate values. Okay. So let me show that for you, that to you as well. So this time let me make this 5 and let me make this D. Okay. Let me save it and let me run it. Okay. So can you see here? The values can be repeated, but the keys cannot be repeated. Keys should be unique, right? Because you are going to generate a unique hash code for each of the keys present over there, right? So it is very, very important for your key to be unique. Yes. So what else we have seen? How to print the contents of our hash table, how to get the value with the help of a key, how to delete a particular value pair, key pair. So this time let me delete 5, right? So let me save it and let me run it. Okay. So can you see here? This 5 is deleted once I write the statement, right? But here I'm not deleting it. So if you run it, it is going to print here 1, 2, 3, 4, 5, right? And then I'm going to remove, okay, what? 5. So it is going to print 1, 2, 3, and 4. That's it. It's not going to print the key and value pair 5, right? So these are the few methods of your hash table class, and this is how you are going to declare and use it. Okay, so I hope with this example you have understood how a hash table works, and we cannot store null values either in the place of key or value, and our key should always be unique. Okay, but your values need not be unique, it can be repeated. Fine. So I hope with this you have understood how a hash table works. Thank you. Now we are in our next topic, which is hash map. Okay. Now what is this hash map? This hash map is again a class which is implementing the map interface. All right. So here, whenever you insert the elements inside the hash map, there is no order maintained, right? So the order in which you insert the elements is not going to be maintained here. Okay. And it can also have one null key, okay, and multiple null values. Okay, so hash map is nothing but a combination of keys and value pair, right? And here you can have one null key but multiple null values, and more than one null key is not valid. Okay, so if you do that, what will happen is whatever is the latest value of that particular key is being considered inside the hash map. All right, so what we'll do is we'll quickly jump to the demonstration part and see how exactly this hash map works. So this is one example for hash map implementation. So starting from the beginning, we have to import this hash map class from the java.utility library. Okay, it is present over there. And once we do that, we have our class hash exam over here. We are starting with our main function, and then how to create or instantiate a hash map class. Okay, so hash map, in this particular example, we have string as our key and integer as our value. It can be anything, okay, combination of two strings or integers. It's up to you, the programmer, right? So here I want to store the detail of an employee and his or her salary. Okay, so string will be the name and integer will be the salary. Fine. And then this is the way you are going to instantiate your HashMap object. So here I've taken HMap1 as the name. Fine. And then to allocate the memory, we are going to use the new operator. So new HashMap, angular brackets can be left blank. Okay, because whatever you specify on the left hand side, the same thing will be initialized here. Fine. So the next thing is to add values or add elements to HashMap. Okay, so how to do that? Simple, use the object name HMap1 dot put method. Okay, so this will be the first value to get inside our HashMap. So here John is the key, the name of an employee, and the salary associated to John, which is the value. Alright, so through this key we are going to get this value, and this particular element is being converted into hash code. How? Because we are passing keys to all our elements here, right? So that key has to be hashed, right? So that easily you can perform your operations such as search, deletion, insertion, right? So for that reason we are going to hash it. Now similarly we are going to insert 4 such elements into our hash map. Fine. So once we insert, to display the contents of our hash map, we are going to simply use the object name, that is HMap1, inside our print statement. Fine. And after this, we can also print the size of our hash map using the size method, like this. Alright. So here the size of the hash map is, it is going to print it. Fine. And then if you want to check for a particular key, if that key is present in the hash map or not. So for that you can use this contains key method. Okay, so what we are going to do, if hmap.1 contains key, we are going to pass the key value here, map. Alright, and this, if it returns true, always remember dot contains key will return true or false, a boolean value, right? So if this is true, then we are going to get the value present at Mac. That is, whatever value Mac is pointing to, we can access it using the get method. Fine. So only if this key is present in our hash map, only then it is going to execute. Otherwise, it is not going to execute. Now what we'll do is, we'll quickly run this code, check the output, and try to modify our code a little bit. Fine. So let me run it. So can you see here? We have 4 elements here, right? John, Frederick, Mac, Amy. So can you see here? It is not going to maintain the insertion order. Okay. See, first John should have come, then Frederick, then Mac, and then Amy. But can you see here? It is simply inserted in a random way. It is not going to maintain the insertion order. Okay. That is the point you have to remember about the hash map. Fine. And then we are going to print the size of our hash map, which is nothing but 4. And then we are going to search for this particular key Mac if it is present in our hash map. If yes, then we are trying to access the value with the help of that particular key, which is 25,000. That is the salary of Mac. Fine. Now what we'll do is, we'll try to modify our content. So suppose Amy got some promotion, okay, and the salary got increased to 30,000. Okay, so what we'll do is, I'll simply write hmap1, okay, and then dot put. Okay, here let me use the same key, Amy, and the salary is now upgraded to 30,000. Fine. Or let me make it 36,000. Fine. And then we'll try to print the contents of our hash map. So what should happen now? This Amy, what we have here with the value 27,000, should be updated with the latest value, that is 36,000. Alright. So let's check that whether it is working or not. Can you see here? The latest value is updated to 36,000. The previous salary of Amy was 27,000. Fine. Now, suppose you want to create a new hash map with the same elements present over here. Okay, you need not again use these 4 steps to insert. Okay, what you can do is you can simply instantiate one more object of type hash map. Okay, so for that, what I'll do is I'll just copy the statement, and here I will write hmap2. Okay, and here I'm going to pass hmap1. All right, so what I've done here, I have to create exact copy of the elements present in hashmap hmap1. Similarly, I'm going to instantiate one more object hmap2 with the same elements present in hmap1. Fine. So let's check that. So let me print hmap2 here. Fine. So let me save it. Let me run it. But before that, let me just type in here system dot out dot println. Okay, so hmap2. Okay, so let's check if we are able to copy the contents or not. Okay, so what is happening here? So it is displaying the previous contents, it is displaying the size, it is displaying our print statement, but it is not displaying the hash map 2 here, what we have over here, right? So what to do? Okay, what is the solution for this? What you can do is you can simply copy these statements. Okay, and then instead of doing this, okay, you can leave it blank, and here you can make it like this. Okay, and let me change the values. So let me write Maven, let me write, then let me write Kemo here, and let me write. Fine. So now what should happen ideally? So let me do this. Now if I print hmap2, okay, so let's quickly run and check. Okay, so can you see here? So this is the content of our hmap1 object. The size of hmap1 is 4, and then hmap2 we have these. Fine. So I hope with this you have understood how a hash map has to be instantiated, how to use the methods associated with the hash map, and what are the differences. Fine. Now one last thing to check is, what if I give a null value here? Okay, will it work or not? Fine. So let me just save it and run it. Okay, so can you see here, one null value is allowed, that is what it is printing here. Fine. So I hope with this you have understood how a hash map works. Fine. Thank you. Now we are in our next topic, which is linked hash map. Okay, so it's nothing but combination of your linked list and the hash map. So how linked hash map will help you in operations such as searching, deleting, and other methods, right? So let's check those with the help of a demonstration. So here's the code for linked hash map. So what I'll do is I'll explain line by line how linked hash map can be implemented and what are the different methods in regard to the linked hash map. All right. So first of all, we need to import this library, that is java.utility completely. Okay. So because we are using different classes of this java.utility, that is the reason we have put a star here. All right. Or if you want individual, you can do that as well. Now here we have our class LinkedHashMap, and then we have our main method. Fine. And then this is how we are going to create instance of your linked hash map class. All right. So linked hash map, here in the place of key and value, I have string. Okay. It's up to you. If you want integer here, you can make it integer. If you want string, you can make it string. All right. So in this case, I want to store the country names with the capital city. Okay, so wherein both are of type string. So that is the reason I have defined them as string in the angular brackets. And then I've given LHMap as the name for this particular instance. And on the right hand side, I'm going to allocate the memory for my linked hash map. Fine. Now, the most important thing here is how different is this linked hash map from other collections. Okay. So it maintains the order in which you are going to insert the key and value pairs inside the linked hash map. Okay, so for example, if I have inserted Oman Muscat, that will be the first one in your linked hash map. Next, it is going to follow India with Delhi. Okay, so it is going to maintain that insertion order. Okay, we'll see that with the output. Fine. So with the help of put method, I'm going to insert these key and value pairs into my linked hash map. Fine. So after insertion, we will also check out few different methods. Okay, so first of all, we are going to print the contents of our linked hash map. Just simply use this object LHMap. Fine. And then we are going to print the size of our map with the help of this method size. And then for any key you can get the value. Okay, so that can be done with the help of this get method. Okay, so lhmap dot get Oman. Okay, similarly if you want to get for like Russia, okay, you can do that as well. So let me just change it. Fine. So you can pass any key here, and then I'm going to check, does it have Russia key, yes or not. So dot contains key is the method to check if a key is present in our linked hash map or not. Okay, it is going to return true or false, a boolean value. Fine. So this is your dot contains key method. And then if you want to delete any particular value, okay, so what you can do is you can use the dot remove method as I have typed it here. Okay, so I'm going to print that I have removed this particular element from my map. Okay, that is what this dot remove method will do. And then finally, again, we are going to simply display the contents of our linked hash map. Fine. So let's execute this first and then try to modify and see what are the different things related to a linked hash map. Fine. Let me just save it and then run it. Okay. So can you see here? This is the way I have inserted my values in the linked hash map, right? So first we have Oman Muscat, then India Delhi, right? And then Russia Moscow, and then Japan is equal to Tokyo, right? And the size of our linked hash map is 4. And the value present at the key Russia is Moscow, right? Key are nothing but the hashed code, right? Which can contain some value, because the hashing code will help you for the faster operation for retrieval or deletion or any other operation. And then we are going to delete the element Oman with the value Muscat. Fine. And then we are going to simply delete the latest content of our linked hash map, which is India, Russia, and Japan, because we have deleted the Oman and Muscat key and value pair. So we have deleted that using this dot remove method. Now, this linked hash map can also contain null value in the place of a key. Let us check that. So what I'll do is I'll simply type null, and then let me store Tokyo itself. Let me try this. So LH map. Yes. Fine. Let me save it and let me run it. Fine. So can you see here? It is storing this value Tokyo with the null key. Okay, so one null key is allowed in a linked hash map. Okay, can you see here? Now what I'll do is I'll try to store one more null key. Okay, and let's check what will happen. So what I'll do is this time let me store something like Canberra. All right, and now let's check what will happen. Okay, so can you see here, it ignored the null comma Tokyo pair, and it has considered only the latest null key and value pair, right? Which is null is equal to Canberra, null is equal to Canberra. Okay, so it is going to store only one null key, not more than one. Okay, so that is how a linked hash map works, right? So can you see here we have two, right? Now let me store null here as well. Okay, let me do that. Let us check what will happen. Okay, now let's run it. So null is equal to null. Can you see that? And then let me give null here, and this time let me Maldives. Okay, and this will be null. So let's check whether it will store two null values or not. Okay, so we have two null values and one null key. Okay, let's check whether it will work or not. So let me run it. Okay, so let me show you what is happening over here. So can you see here, it is storing null is equal to null. Okay, plus it is storing null as the value. So you can store more than one null value, but you cannot store more than one null key. Only one null key is allowed, that's it, not more than one. So this is how a linked hash map works, and this is how it is different from other collections. It will maintain the insertion order. You can store one null key, not more than one, but you can store more than one null values, right? So here I have stored two null values, right? Can you see here? So this is how your linked hash map works. So I hope with this you have understood all the methods and the instantiation part of a linked hash map. Thank you. Now we are in our next topic, which is HashSet. Okay. Now this HashSet collection implements the set interface. Okay. And here you cannot store the duplicate values, right? Because that depicts your set interface, right? So duplicate values are not allowed in a hash set, right? But the values can be null. Fine. So how does a hash set work and what are different methods of a hash set? Let's try to understand. So this is the code or the implementation of hash set. So we need to import java.utility to make use of this hash set in our program. Now this hash set needs only one argument, that is we are going for string in this particular example, right? Similarly, you can store or you can pass integer, string, float, any other data type, right? But in this particular example, we are going to use string. This is the instance what we are going to create for a hash set. And on the right hand side, we are going to allocate the memory using the new operator, right? So it's not mandatory to write string here as well, right? And then instead of put method, okay, we are going to use the add method to add the elements to our collection, right? So here we are going to use the add method to insert values to a hash set. Fine. So similarly, we are going to insert three values in our hash set, right? How do we do that? Simple. You have created an object of hash set here. So headset dot add a country name, Italy, right? So once you execute this statement, that particular country name will be added to the hash set. Now it's not mandatory that it should follow the order in which you are giving it, right? So set has its own set of rules, right? So here internally hashing is being applied for the values and a hash table is being created to store all the values with the hash code, right? So if you perform any operation such as search, delete or insert, that particular hash code plays an important role. Fine. So it's a combination of hashing and the set properties that gives you your hash set. Fine. And then once I've inserted, we are going to check the contents of our hash set. Now what I'll do is let me add one more content. So headset dot add, let me add one more country. So let me add Maldives. Okay, let me add Maldives and end it with a semicolon. Fine. Now I have added 4 countries here, right? And then what I'm going to do is I'm trying to demonstrate the remove method. Okay, so HashSet.remove will find out this particular element, that is Cuba, and try to delete it from our hash set. And then here I'm going to type Cuba, right? So after removing Cuba, what is our latest hash set list? Fine. And then we are going to check using the contains method if this particular country, Italy, is present in our hash set or not. Okay, so it is going to return a boolean value that is true or false. Fine. And then we are going to iterate through our list, right? So here we are going to iterate over our hash set. So for that, what we have done, we have used the iterator method, HashSet.iterator, while vals.hasNext, that is if any element is present, right, it will return true. And once it is true, we are going to print the contents using vals.next. So again, this next method will check if there is any element present or not. Fine. So first let me execute this and let's check the output. So can you see here? We have 4 country names: Cuba, Maldives, Italy, Russia. But the insert order was Italy, Cuba, Russia, and Maldives. Can you see that? It is not going to maintain the insertion order. Fine. And then after removing Cuba, with the help of this remove method, we are seeing Maldives, Italy, and Russia. Fine. And then we are going to check if Italy is present in our hash set or not, in the list or not. So it returned true. That is the Boolean value. Fine. And then we are going to display the contents of our hash set. Fine. Now let us check few more things. Okay. Now what I'll do is I'll try to insert a duplicate value. Okay. Let me insert this Maldives second time. Okay. So let me write here duplicate value. Okay. So let's check if it will print this or not. So I'm running it. Can you see here? It is not going to print that particular duplicate value. Can you see here? Cuba, Maldives, Italy, Russia. That's it. Fine. Now let's insert a null value and check whether it will take or not. Okay. Let me insert null. Let me save it and let me run it. So let me just write a comment. So null value. So if I run it, can you see here? It is considering the null value. Fine. But it will not take the duplicate values. Now let me insert one more null value and check whether it will take or not. No warnings. Let's go and check. So can you see here? Only one null value, right? Because set property says no duplicates, right? So this is what it is depicting over here. Fine, let me just delete that. All right. So no duplicate values allowed in a set, but a null value is allowed. That too only one. Now what else? There are different methods on which you can try out your hash set properties. Fine. So hash set plays an important role because here it's a combination of the hashing technology plus the set properties, right? So this plays an important role whenever you are, building an application or writing a Java program using collections, right? So that is why a hash set collection is a very, very important concept. Fine. Similarly, what you can do is you can create one more instance. So let me just copy this. Okay. And let me just write it here. So HashSet 1. Okay. So what I can do is using this, okay, I can insert some more values. HashSet1 dot add, let me write some country name, USA. Fine. And let me just display that as well. So this will be HashSet 1. Fine. So if I run it, so can you see here? USA. Right. Now this instance is different and this instance is different. Fine. So remember that. This is a different instance what you have created and this is a different one. So in HashSet you have these countries as values and in HashSet 1 you have USA. Fine. So I hope with this you have understood what is a hash set. Okay, how does it work, what are the different properties and methods with which you can explore hash set collection. Fine. Thank you. Now we are in our next topic, which is linked hash set. Now what happens in linked hash set? So it's a combination of linked list with the set properties, right? But the most important thing to note here is it will maintain the insertion order. Okay, so unlike hash set, linked hash set will maintain the insert order in which you are going to insert the elements in a linked hash set. Okay, and it will also store a null value. But what about duplicate values, right? Will it store or not? What we'll do is, to try to understand this better, we'll quickly move to the demonstration part and check all the properties of this linked hash set. So this is our implementation part. So here we have this code. Okay, don't worry, I'll explain this line by line. So first of all, we need to import this java.utility.linkedHashSet, right? Because all our collections are present in this java.utility library. Fine. So once you've done that, we can begin our programming with the class, and then here we have our main class. All right. So first and foremost thing when we start implementing our main method is we need to instantiate our linked hash set. Fine. So for that, what I've done, linked hash set, I want string data type as my values. Fine. So I'm using that. You can use anything. You can use integer, float, double. Fine. And then I'm going to create an object of type linked hash set. And then using the new method, I'm going to instantiate the memory. Fine. And then what we're doing is we need to insert or add values to our linked hash set. Fine. So for that, what we are doing, we are using the add method, just like the hash set. Fine. Now the major difference here is in hash set, it does not maintain the insertion order, right? But here it's a combination of the linked list and the set interface, right? Combination will give you the insertion order method, right? So say for example, if I have inserted in this particular order in my linked hash set, so the same order is being maintained here. Fine, we'll check that. And then first what we are going to do is we are going to print the contents of our linked hash set. All right. Then we can also print the size of our linked hash set with the help of this size method. Okay. And then we can also check if any value is present in our linked hash set or not with the help of this dot contains method. Okay. So here we are checking if CCC is present in our list or not. Similarly, with the help of dot remove method, you can remove any content of your linked hash set. Fine. And then finally, we will also print the latest collection of our linked hash set. Okay. So what I'll do is first let me run this code. Then we will also check out few more properties of our linked hash set. Okay. So let me save it and let me run it. Okay. So can you see here? It is displaying the same contents in which it was inserted: AAA, BBB, CCC, and DDD. Fine. And the size is 4. And next we are going to check if CCC is present or not with the help of dot contains method. So this will return only the boolean value whether true or not. And then I'm going to remove DDD from my linked hash set. So the latest values present in my linked hash set are AAA, BBB, and CCC. Triple D was removed with the help of dot remove method. So now what we'll do is we'll try to add same content. Okay. So what I'll do is let me add LSET dot add. Okay, let me add AAA. Okay, and then let me also add a null value. Okay, let's check whether it will take or not. And this comment, let me put it beside this. And here, let me just write add null. Right. So let's see what will happen. So semicolon outside. Yes. So what is happening here? Triple A is being considered only once. That is, no duplicate values are allowed here as well, because it is following the set properties. And null is allowed, so it is being stored. And now the size is 5, C is present true. So the latest collection is AAA, BBB, CCC and null. Okay. So no duplicate values are allowed in LinkedHashSet as well. Okay, because it is following the set properties and it says it will store only unique values, right? So it is not going to store the duplicate values here. Fine. Now the most important thing is, whenever you're trying to store such contents or values in your collection, here internally a hash table will be created with hash codes, right? So whatever value you're trying to store, each value has an associated hash code, right? So for operations such as, displaying the contents, displaying the size, or checking if any value is present, or delete using the dot remove method, all these operations are quicker because of this hash code and the hash table maintained in the background. Okay, so these play a very important role in our Java collections. Fine. So I hope with this you have understood how this linked hash set works. Okay, let me show you one more thing as well. So this is not mandatory. Okay, this will also work, because on the left hand side, if you mention, it is understood that the same value you are going to pass it here. Fine. So let me also show you one more thing. So let me copy that and let me paste it here. Okay, so here I can create one more instance, okay, with the help of LinkedHashSet class. So here it is going to implement the set interface. Okay, remember that. Now after this, what I'm going to do is, here let me just write LSET2. Okay, LSET2, and here let me add null. Okay, that's fine. Okay, so now let's check what will happen. We should also print the contents, right? So what I'll do is, I'll copy this, I'm going to paste it here, but this time it is for the next instance, LSET2. Okay, let's see what is happening. So can you see here? Linked HashSet contains AAA. Now this is a different instance what you have created, right? And this is different. Okay, so here for the second instance, I'm just going to print the content, which is AAA. Okay, and then let me add this null value as well. Okay, so now if I run it, let me add two null values and check what will happen. Okay, so will it take one null value or two null values? Let's check that. So what is happening? It is considering only one null value. Okay. So I hope with this you have understood what is a linked hash set, how is it different from a hash set. So here the important thing to note is it maintains the insertion order, unlike a hash set. Okay.
Here's a quick summary of what we covered. We began with an introduction to hashing, exploring its purpose, implementation, and how it enables efficient data retrieval. Next, we learned about how hashing works, the importance of hash functions, and methods for collision handling, including chaining and open addressing. We then explored key data structures like hash table, a synchronized key value mapping, a hash map, and unsynchronized alternative known for its speed. Additionally, we discussed LinkedHashMap, which preserves insertion order, HashSet for managing unique elements, and LinkedHashSet, which combines uniquenesses with order preservation. This overview of hashing concepts and data structures provides a strong foundation for efficient data management in programming. Thanks for watching. If you find this video helpful, don't forget to subscribe our channel for more videos like this. See you next time.